So far in this course, we have talked about things like operations, linear equations, and things with exponents and square roots. And now that you have all that knowledge, we can now apply that knowledge and talk about polynomials. So in this unit, we are just going to be doing, in essence, operations. So like operations like addition, subtraction, multiplication, and division with polynomials. But before we do that, in this first section, we're going to be talking about what exactly a polynomial is and the different parts of it and a couple other things. So taking a look at the first part, we're just going to be talking about the different parts of a term within a polynomial. So a polynomial is made up of terms separated by a plus or a minus sign, and each term has specific parts. So typically, most terms will have a variable, and we've seen that word before. A variable just means whatever letter we are talking about. Usually it's x that's representing an unknown value. And then if we have a variable, we will always have a coefficient. So that's one thing to point out, because the coefficient is the number that's being multiplied by the variable. So if there's no variable in a term, we don't have a coefficient. So that's just one thing to point out. So for example, like if we have 5x as the term, the coefficient is 5. And that brings us directly to what a constant is. If there is no variable, then we have a constant instead. So if we have a term that just has a number with no variable, we're talking about a constant. So typically the constants we put at the end of a polynomial. So you usually see, for example, like a +7 at the end of a polynomial. But one thing is that polynomials won't always be like what we call standard form, which we will see here in just a couple of minutes what standard form looks like. But just in general, just know that the constant is the term without a variable. And then we also have exponents in a polynomial. And then also one thing to take note here is that by definition, polynomials must contain only whole non-negative numbers. So for example, 1, 2, 3, even 0 works. But what that means is that a polynomial cannot have a negative exponent or a fractional exponent. Now, I should take this out because we haven't talked about fractional exponents in this course, but just know when I say fractional exponent, I'm referring to square roots. Without further ado, let's get into how we classify polynomials. So we can typically people will name a polynomial based on how many pieces they have or terms they have. So when we have a polynomial that has one term, for example, just 4x, we call it a monomial. If it has two terms, we call it a binomial. If it has three terms, we call it trinomial. If it has anything more than three terms, we refer to it as a polynomial. So with that in mind, let's take a look at example 1. So we are asked to classify the polynomials below based on their number of terms, then determine the coefficients and the constant in each polynomial. I should put parentheses around the s, coefficients, because we don't know if there's multiple coefficients. But anyways, taking a look at example 1, we have two terms, which that means we are dealing with a binomial. And then for our coefficients, recall that's the number that's being multiplied by the variable. And in this case, the only number that's being multiplied by a variable is this 2 here. So our only coefficient is 2. And then our constant is the number that doesn't have a variable being multiplied to it. In this case, our constant is 4, because here there's no variable attached to it. Alrighty, and for example 2, I encourage you to pause the video and try this one on your own. And let's go through this together. So taking a look at this polynomial, we have 3 terms, which means we're dealing with a trinomial. And for our coefficients, recall those are the numbers that are being multiplied by a variable. And in this case, we have a 5 here that's being multiplied by the x squared. And we also have an invisible -1 here that's also being multiplied by that x. And if you didn't catch that, that's okay. But whenever you just see like a variable on its own without a number in front, there's always an invisible 1 there hanging out. Because what is 1 times x? Oh, that's just x, right? 1 times x is just x. So a lot of times people don't write that one and they just leave it out. So if it helps you, you can write down 1 next to the variable, but just keep that in mind. And then last but not least, the constant is just that -4 hanging out there. And that's it. Alrighty, so taking a look at standard form. So the standard form of a polynomial is just where the exponents decrease from left to right in order. So taking a look at this example here, this polynomial is in standard form. Notice the exponents, they decrease in value from left to right. So it goes from 3 to 2 to, there's the invisible 1 here, so it goes 3, 2, 1, and then there's no more exponents. So that's all standard form of a polynomial is. So taking a look at example 2, we are now asked to rewrite the following polynomials in standard form. So looking at example 1, our highest exponent is 2. So I'm going to go ahead and first write that -x squared out in front. And then there's an 8x here, so I'm going to go ahead and write that. And then that 4 here, I'm just going to go ahead and bring that along. And that's it. Alrighty, I encourage you to pause the video and try example number 2 on your own. And assuming you have given it a go, let's go through this together. So for example 2, taking a look, my highest exponent is 3. So I'm going to go ahead and bring that term, write that term first on the left. So we have -4v cubed. And then I'm going to go ahead and see what comes next. In this case, the -v squared term comes next because it's in descending order, 3, 2. And I have to look for the next one, which would be here, 10v. So I'm going to go ahead and add that 10v. And then I'm going to bring that +3 at the end here. And that's it. Alrighty, so the last thing we're going to talk about here is what exactly is a like term. So we've seen what a like term is before in linear equations, but sometimes when we introduce this idea of polynomials, it can be confusing for students. So I'd just like to have this here just to make sure that we're all on the same page. So like terms within a polynomial are terms that share both the same variable and the same exponent. So I'm going to go ahead and highlight that here. They need to share both the same variable and the same exponent. While multiple terms may have the same variable, they are only like terms if their powers match. It's a common mistake for students just to see, like in polynomials, they'll be like, oh, hey, look, both these variables are the same, so therefore they're like terms. But the one thing that they don't pay attention to is the powers. So the powers need to match as well as the variables. So taking a look at example 3, let's go ahead and go through this together. So we have 4x squared and 9x squared. So the first thing you have to look is the variables the same? And in this case, they are. We're dealing with an x and an x, so those are the same. And now to take a look at the powers. Both the powers are equal, so these are like terms. Taking a look at example 2, we have 2x squared and 3x cubed. So the variables are the same, they're both x, but our powers don't match. We have a 2 and a 3. So these are not like terms because the powers don't match. Taking a look at example 3, I encourage you to pause the video. I actually encourage you to pause the video and do both example 3 and 4 on your own. And assuming you have gone through them both, let's go through this together. So for example 3, we have 4v and 9y. And right away, we can tell that these are not like terms. And that is because the variables don't match. Alrighty, and taking a look at example 4, both the variables are the same. They're both z, but the powers don't match. We have a power of 5 and this invisible power of 1 here next to that z. So because the powers aren't the same, these are not like terms.